Okay, so in these videos, I'm going to show you how graphing sine and cosine functions, how to go about doing that. They both work kind of the same, and it's really not too bad. There's just kind of a couple things to remember. So I'm going to go through a couple examples here. So here we've got this sine function. We want to identify the midline, amplitude, period, and phase shift. And then we're going to sketch it. So those are kind of the four things that you need in order to graph any of these. Okay, so we'll start with the midline. The midline of one of these functions is always y equals, and then it's whatever number is added or subtracted from the sine function or cosine function as a whole. So we've got sine of lots of stuff here times the number -2, and then plus 1. And so that positive 1, that's the midline. So y equals 1 is our midline. Okay, next amplitude. Amplitude is the absolute value of the number in front of the trig function. So here I've got sine, and the number in front is -2. The absolute value of that is 2. So that's my amplitude. The period for sine and cosine, the period is given by 2 pi divided by the number in front of this variable x here. So in our case, 2 pi over 1/2. 2 pi over 1/2. And then you want to simplify that. So this is 2 pi divided by a fraction is multiplied by the reciprocal, so times 2 over 1, which is of course 2, and then 2 pi times 2 is 4 pi. Okay, that's the period. And then finally we get our phase shift. There are a lot of ways to get the phase shift. Well, I won't say a lot. There's several different, there's a couple different approaches that people take. You might see others if you look for other videos about this. What I'm going to do here is your phase shift, you take the thing that you're doing sine or cosine of, and you set it equal to 0. Okay, take the whole thing, whatever's there, set it equal to 0, and then solve for x. So 1/2 x plus pi over 3, set that equal to 0, and then we solve for x. So if we subtract pi over 3 from both sides, 1/2 x equals negative pi over 3, and then multiply both sides by 2 to get rid of that 1/2, and we get x equals negative 2 pi over 3. Okay, so that's our phase shift, and if you're describing that, you'd say it's 2 pi over 3 units to the left because of the negative. Okay. All right, once you've got those four things, you're ready to start graphing. Okay, we're going to start with our midline. The midline is y equals 1. I'm going to go and just let that be 1 right there. And that is, I'm just going to do a dashed line because it's not actually part of the graph. It's just a line that we use as we graph. Now, sine and cosine, they're waves. Okay, they look like that. And the midline is just that line that goes, that's right in the middle. Okay. So that's my midline, y equals 1. Okay. The next thing we're going to do is we're going to go to the phase shift. Okay. The phase shift is negative 2 pi over 3. So I need to, somewhere on my x-axis, have a 2 pi over 3. I'm just going to let each of these, just to keep it simple, I'm going to let each of these grid units be pi over 3. So this will be negative pi over 3. This would be negative 2 pi over 3. Okay. And so on. So at negative 2 pi over 3, and this is where it's important whether it's sine or cosine, and we'll look at some cosines later. But for sine, okay, at your phase shift, you have a point on the midline. Okay. And I like to think of this as a starting point, and in some other videos that I've done, I call it the starting point. So the sine has a starting point on the midline. Okay. From there, we're going to use the period. Okay, let's review real quick what we've done. We've had midline, and then we have a point at the phase shift on the midline, and then we have the period, and the period is how far we're going to go horizontally to get to the end of a cycle. Okay, and I think actually maybe I made my scale too big here. Let's see. This would be pi over 3, 2, 3, 4, 5, 6. That's 7 pi over 3, which is not quite far enough. But you know what I'm going to do? Because I've got technology here, which is amazing. I'm going to take all this. I'm going to move it over. Oops, I just got an extra little piece over there of that. Okay. So let's see. Each tick is pi over 3. So pi over 3, 2 pi over 3, 3 pi over 3 is pi. 4, 5, 6 pi over 3 is 2 pi. Okay. 7, 8, 9 pi over 3 is 3 pi. And we'll go one more. Now let me point out why I'm doing that. From this, we need to go a total of 4 pi. Okay. Now if I'm counting by pi over 3, 4 pi is, I want over 3. So I have to multiply by 3 over 3. That's 12 pi over 3. So I'm going to move 12 tick marks from this point. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That right there is the end of that cycle that I'm just going to start over here. Okay. With sine, we have a point halfway between those. In other words, we're going to go, instead of going 12 pi over 3, we're going to go 6 pi over 3. 1, 2, 3, 4, 5, 6. Okay, there's another point. All right, now I'm going to draw a couple things just so you can see some possibilities here. Sine starts, and it either starts by going up and then down through that point and then back. Okay, or it starts by going down up to that point and then back to that to finish the cycle. So the way you know is the sign, and by sign I mean positive or negative, in front of that sine function. Okay, this is a negative 2 in front. That means it starts by going down. If it was positive, it would start by going up. So now it's going to start by going down. Okay, and then we just need to find 2 more points. Okay, and this is where we're going to use the amplitude. For our amplitude, that's how far up from the midline and down from the midline we can go. So since each of these is 1, we're going to make it up to 3, and we're going to make it down to a negative 2. Right? And the peak or dip, the lowest point or highest point, it happens halfway between these points on the midline. Okay, so that was 6 pi over 3, or 2 pi. So I go 3 of those, 1, 2, 3. That is where the minimum is going to occur. And then on the other side over here, I go 1, 2, 3, and that's where the maximum is going to occur, up at 3. And then I just draw my sine function. And this, of course, keeps going. I could continue and say, to the next one and the next one and so on forever and ever, okay? It just keeps waving up and down and up and down. Okay, let's look at another one. Same idea. Okay, we've got this sine function. We're going to identify those 4 things and then graph. Okay, so midline. The midline is y equals the number outside of the whole thing that we're adding or subtracting. So that's the minus 2 right there. So y equals negative 2 is my midline. I'm going to go ahead and draw that. That's, if I just let each of these values be 1, that would be down to negative 2. And that right there is going to be my midline. You don't have to draw a dashed line or anything for the midline if you don't want to. I just like to see it when I'm drawing. Okay, next is the amplitude. Okay, the amplitude is the absolute value of the number in front of the sine function. So that's going to be 3. Okay. The period is 2 pi divided by the number in front of the x, and that's going to be pi. Okay, that's that pi right there. So 2 pi divided by pi, which is just 2. And then we need our phase shift. Phase shift. And to get our phase shift, we take the thing here, we set it equal to 0. Now let me point something out. If it looks like this is a common thing to see, a number and then parentheses x with something else. That's very common. And when you see it like this, it actually means that you just can divide out that number in front. You end up with x minus 1 equals 0, and then add the 1, and you get x equals 1. In other words, when you see it in this form, a number and then parentheses with x plus or minus something, That's going to be really quick to solve. It's just the x equals the opposite of that number. All right, x equals 1. That's my phase shift. All right, I'm going to go ahead and start drawing here. Because my period is only 2, I don't want it really cramped, so I'm going to let each box here be a half. So this is going to be 1, 2, 3, okay, and so on, -1. Okay, we're going to start drawing. This is a sine function, so I'm going to go to my phase shift, and I'll have a point on the midline. So at x equals 1, I have a point on the midline. So there's a point right there. Okay. That's where a cycle is going to start. A cycle will end after I move the period. So from 1, I move a period, which is 2. So 1, 2, over at 3. I'm going to have another point there. And then with sine, I'm going to have another point halfway between those, which is, of course, just right there at 2. Okay, and then the sine function, when I start here, I can either start by going up or by going down. Okay, and to figure out which one, that's where I look at the number in front of the sine function. It's a positive number, which means I start by going up. Okay, and then I need my maximum and my minimum. My maximum I find by taking my amplitude and moving that distance up from the midline and down from the midline. So since these are each 1, -1, -2. Okay, from -2, if I go up 3, 1, 2, 3, puts me at 1. Okay, so halfway between these points, which is at 1.5, it's going to have a y value of 1. And then these other 2 points, halfway between these, I go down 3, 1, 2, 3. That gives me a point there. So it's going to be, that's going to be 1 cycle of my sine function. And again, you can draw as many of these as you feel you want to. But as long as you can draw 1 full cycle with the proper points, then we're good. Okay, let's jump now into an example of cosine, and let's see how that differs. We're going to start still by finding those same 4 things. Okay, our midline. Our midline is y equals the number added or subtracted from the full function. Okay, that's the number that's not multiplied by the cosine. So that's the 2 here. So y equals 2 is my midline. I'm going to go ahead and draw that. That's each of those squares is 1. Okay. My amplitude. Amplitude is the absolute value of the number in front of the cosine. So that's going to be 4. My period is 2 pi divided by the number in front of x. So that's 4 times x, so 2 pi divided by 4. And that is pi divided by 2 if I reduce that. All right, my period here is pi over 2. Okay, I'm going to tell you this. The scale that I like to pick, if I'm just drawing by hand like this, and when you guys work on the problems online, you'll see it just creates the scale for you. But if you are doing it by hand, what I like to do is I take the period and divide it by 4 to pick what my units are. Okay, so let me just do this, and you're going to see why in a minute here. I'm going to take this and divide it by 4, and that's just going to be, that just is pi over 8. So each square I'm going to let be a pi over 8. Okay, so pi over 8, this is 2 pi over 8, 3 pi over 8, 4 pi over 8, which is pi over 2, 5 pi over 8, 6 pi over 8, 7 pi over 8, 8 pi over 8, which is just pi, okay, and so on. You're going to see why this is useful in a minute here. Okay, the next thing we need is the phase shift. Let's go ahead and do that. For our phase shift, we set the thing inside the parentheses here equal to 0 and solve for x. So 4x minus 3 pi, and we set that equal to 0. So if I add 3 pi to both sides, I get 4x equals 3 pi. And divided by 4, I get x equals 3 pi over 4. Okay. All right, so that is a point, or that's going to be a starting point. Now, because we're doing cosine, our starting point is not actually going to be on the midline. Okay, this is weird. Here's what we do. We're going to go to that, at 3 pi over 4, that is, since I'm doing pi over 8s here, that's 6 pi over 8. 6 pi over 8. Okay, so that's 1, 2, 3, 4, 5, 6 pi over 8. That's that one right there. 3 pi over 4. And with cosine, to get a point, you go from the midline, and you go the number in front of that cosine function, including the sign in front of it. So it's a negative. So from my midline, I'm going to go negative 4, so down 4. 1, 2, 3, 4. Okay. All right, now you can see if I try to move to the right, I'm going to be going off the graph here. That's fine. I can actually go backwards too. Okay, so we're going to now kind of do the same thing that we did with, well, not the same, but close to the same thing that we did with sine. We're going to go from here. We're going to go the period, which was pi over 2, and in terms of pi over 8, okay, this is 4 pi over 8. Okay, so I'm going to move 4 pi over 8 to get to another point. I'm going to move to the left. So 1, 2, 3, 4 pi over 8. Okay, there's another point. Okay, so this is going to be 2 points on my cosine graph. Now with cosine, you're going to get one more point halfway between these, but it's not right on that. It's halfway between, but on the other side of the midline. Okay, so we've got this midline here. These points were 4 below it, so I'm going to go 4 above it to get my other point. Boy, is that weird. All right, and now we can get 2 more points now on the midline, and it's just halfway between those. So we had this at this pi over 2, and then this point here, which is pi over 4. Halfway between those, we get a point on the midline. And then on the right side, halfway between these two, we get a point on the midline. Essentially, it's like if you just do a straight line from those points, you'd get a point on the midline. And then we draw one cycle of the cosine function. Now this, it starts at a minimum or a maximum, okay, depending on where you do it. And so make sure you do the nice curve, because you don't want to just draw lines. It's not just lines, it's a nice, beautiful curve. Okay, and that's one cycle of the cosine. And we could draw more if we want. Keep going there, and we can see like each unit is where we reach our maximum, and so on. And that's our cosine graph. So let me point out now why I like this divide by 4 thing. We know that to find other points, we kind of cut it in half to get another point, and then we cut that in half again to find another point. So we're cutting it into fourths. So by using the period divided by 4, it makes each of those points just 1 unit apart, which is nice. If you want to go further, you could divide it by 8 so that it's a little bit more spread out. But it should be at least like that should be its biggest, I should say. Like when you divide by 4, that should be the biggest thing that you use, the pi over 8 as a unit. You could go smaller than that, but that's kind of a good rule of thumb. Let's do another one. We've got another cosine here. Okay, so we're going to go through and do that same process. So we start by finding our 4 things. So midline is always y equals the number added or subtracted, so that's -1. The amplitude is the number in front of the cosine, which is, I should say the absolute value of the number in front of that. So that's just 5. Then our period. The period is 2 pi divided by the number in front of the x, 1/2. Okay, simplify that. That's of course 2 pi times 2 over 1. That's 4 pi for our period. And then our phase shift. Phase shift, which we get by taking the thing inside and setting it equal to 0. Solve for x, and of course here we just get x equals 0. Okay, so I am going to start drawing. Now, as I said, I like to take my period and divide it by 4 and say that's the biggest that each unit should be in the horizontal. So if I divide that by 4, I get just pi. So I can just go by pi's here. I think I'm actually going to cut that in half again, just to sort of be a little bit more spread out. So I'm going to go by pi over 2's here. So that's pi over 2 makes this pi, 2 pi, 3 pi, and 4 pi out here. Okay. Draw our midline at y equals -1. And now our first point, we go to our x value for the phase shift. It's x equals 0. For cosine, we go from the midline vertically the number in front of the cosine. So from the midline, we're going to go, that's +5, we're going to go up 5. 1, 2, 3, 4, 5. There's a point. Okay. From there, we're going to move horizontally the period to get another point. So I can go to the right or to the left. I'm going to go to the right from 0, 4 pi. It goes right there. And then with cosine, halfway between those points, so halfway between 0 and 4 pi is 2 pi, we get a point, but it's on the opposite side of the midline. So down 5 from the midline. 1, 2, 3, 4, 5. There we go. Okay. And then halfway between those 2 points on the midline, we get a point. Halfway between those 2 points on the midline, we get a point. And then we draw our cosine curve. Doesn't have to be perfect. Just make sure it kind of looks like that wave. And then kind of go from there. And that's our graph for cosine. Okay, let's look at now, we're just going to do 2 more examples, and this is, we're going to flip it around and look at, if I have the graph, can I get the formula? So, the nice thing about this actually is any one of these graphs, you can choose either sine or cosine. Okay, any graph, that they're called sinusoids, both sine and cosine are the sinusoids. And either one, we can do either one. So it's really up to you. What I like to do is I like to say from the axis, the y-axis, is the closest point on the midline, as I move to the left or right, is the closest thing on the midline or a maximum or minimum. Okay. Another thing is the maximum or minimum on a nice whole number value? If it's not, then and when I say whole number value, I should say x values. If it's not, I like to steer away from cosine, because cosine, that starting and ending point happens at a maximum or minimum, so it's nice if that's at a whole number value of x. It's not here. From the x-axis, we see actually we have a point on the midline on the x-axis. Okay, so that's sine. Okay, points on the midline. If you start or end on the midline, that tells us sine is probably easier to use here. Okay, so I'm going to use a sine function here. And I'm going to write out kind of the basic form here that you can use anytime you're writing an equation based on a graph. It's a times sine or cosine. And then you can actually keep this simple by doing some number b times x minus c, and then plus d. Okay, and this makes it super easy. Just remember this form. Okay, and then it's super, super easy. We're going to fill all of these things in here. It's going to be pretty quick, okay? I'm going to start with, okay, at this point right here, this is my starting point. Starting point. You don't have to pick that as your starting point. You could pick a maximum or minimum. If you do that, it'd be a cosine function. You could pick another point on the midline, like over here. That could be your starting point. But once you decide your starting point, everything's determined from that, okay? So this is my starting point, okay? The x value there is c. So x minus, that's an x value of 0. So we've got that. Okay. The midline, of course, we know is d. Oh, I don't know why I did plus there. It's not plus. The midline I can see is down here at -2. Okay, and just make sure it's halfway between the maximum and the minimum. I can see my maximum's at 1 and my minimum's at -5. Halfway between those is -2. So I have a -2 over there. Okay. The number in front of the x, this is really cool, because I know that 2 pi divided by that number is the period, which actually means that 2 pi divided by the period is this number. So you can always just do 2 pi divided by the period. Now, the period might be hard to see. In this graph here specifically, we actually don't see, well, I'll say this. You just need to look at how long does it take to complete a cycle. Okay, and I can see that means it has to go down, up, and down, or up, down, and up. Now I see if I start here and I go up, down, and up, it's going to end somewhere over here. It's not easy to see where it's going to end. So instead I'm just going to jump over here and say from this point it goes down, up, and down, lands back at the midline right there. That distance right there is from -5 to 5, that's 10. That's the period. So that's what I'm going to put right there. And then the number in front of sine is from this point here, where do I go? How far up or down do I go? Here, it starts and it goes up, which means it's positive, and it goes up 3. So it's positive 3. And then you just simplify. So we have y equals 3 sine of 2 pi divided by 10 is just pi divided by 5. And x minus 0 is just x. So x. And then minus 2. And that is one possible equation for this curve. Okay, there are actually an infinite number of equations that would fit this curve. You just got to pick a starting point and be consistent from there. Okay, let's do one more. I've got a graph here, and I'm going to say this here. Notice that, first of all, let's find the midline. Okay, from 5 down to -3, that's a distance of 8. So cut that in half, that's 4, and that's going to be the distance I need to go for my midline. So my midline here is at y equals 1. Okay. All right, now from y equals 0, I'm actually going to do this just so I can help you to kind of see something here. Okay, from 0, if you move to the left or the right, you're looking for the first thing that you hit, whether it's on the midline or a maximum or minimum. And it turns out that it's equidistant either way. Okay, there's a minimum to the left one, and there is a point on the midline to the right one. Okay, it doesn't matter which one. If I decide to use the point on the midline, I'm going to write a sine function. If I want to use the minimum, I'm going to use a cosine function, and it's totally up to you. I'm going to use cosine since the last example used the sine. So I'm going to let this point right here, be my starting point. Starting point. Okay, now I know that I'm using cosine. The general form is a cosine b times x minus c plus d. Okay. Some of these are really easy to see. For example, d, of course, is the midline. That's just going to be 1. So I know it's going to be plus 1. I could find, let's do c. c is the x value of the starting point that I chose, which is -1. Be careful. X minus -1 is x plus 1. Now b, I can do 2 pi divided by the period. And I can see the period from the start point. It goes all the way up and then all the way down. It completes a full cycle right there from -1 to 7. That's a distance of 8. That's my period. So 2 pi divided by 8. Cosine. And then a for cosine from my starting point is from the midline, where do I go to my starting point? From my midline, it's down 4. That means -4. And then you simplify. So we have y equals -4 cosine of pi over 4 times x plus 1 plus 1. And that is one possible equation for this. I'm going to very quickly just write out what it would be if it was sine. And I'll quickly walk you through it here. Okay, y equals. If I was doing sine, I would look at a point on the midline. There's a point right there on the midline. Okay, and so I have sine. I know that that's at x equals 1, so it would be x minus 1 in there. The midline's still 1, so it's still plus 1 there. Okay, the period is still 8. The period doesn't change, right? So it's still, well, I'll just say pi over 4. Okay, the 2 pi over 8. And then the number in front is from the midline, from that starting point, what am I doing? From that starting point, I start by going up, so it's a positive, and I go up 4, so it's positive 4. So that equation there is how I would write this curve in terms of sine. You can notice, you see that they have a lot of things in common. They'll always have this number in front in common. But one could be negative, one could be positive. They could both be negative, both positive. Who knows? Okay. The number in front of the x is the same. That's always going to be the same. The number out here, the midline, that's always the same. The only thing that could change is this x plus or minus some number. Those could be different numbers. One could be plus, minus. They could both be plus. They could both be minus, whatever. And this number out in front. So a lot of similarities, but a few differences.